Now we will discuss a little bit more about energy bands. In the case of silicon, so we have a valence band and a conduction band separated by an energy gap. So the question is, why this band, the lower band, is called the valence band. Okay, so silicon have 4 valence electrons, right? So there are 4 valence electrons, and at 0 Kelvin we can see that all the valence electrons are in the valence band. So here we have foreign states and foreign electrons. So all valence electrons are in the valence band. Now I have mentioned that the valence band at 0 Kelvin is completely filled. It is completely filled. Out of the foreign states available, we have foreign electrons occupying them. We have discussed that at 0 Kelvin, silicon acts as an insulator. Okay, we have explained in terms of covalent bonds that at 0 Kelvin, all the electrons are in the bonds and they are not free to move. So the silicon acts as an insulator. So we can explain the same thing in terms of valence band. So we have a completely filled valence band, right, at 0 Kelvin. For conduction, there should be available states, that is states free of electrons in the valence band. So for conduction, we need either empty levels in valence band or we need electrons in the conduction band. So for conduction, what we need? We need either empty levels so that electrons can move in the valence band, or electrons in the conduction band where we have foreign states but no electrons. At 0 Kelvin, there are no electrons in the conduction band and the valence band is completely filled. So let's consider a simple analogy. Here, let's consider this rod as our valence band and this one as our conduction band and this as our barrier or energy barrier. Now we were talking about at 0 Kelvin, okay? At 0 Kelvin, we have said that the valence band is completely filled. So the completely filled condition can be considered as a traffic jam. That means we have cars which are actually charge carriers. So we consider these cars as our charge carriers. At 0 Kelvin, the valence band is completely filled. We can consider it as this road being completely filled by cars. That means these cars do not have any place to move. They are stuck. So this cannot contribute to conduction. And in the case of conduction band, it is completely empty. That means here there is no cars or no charge carriers. So they also cannot contribute to conduction. Okay. So we have a valence band which is completely filled and a conduction band which is completely empty. So there cannot be any movement of charges. Now the question is, what happens if one of these cars gain enough energy? Let's say this car gains enough energy, crosses the energy barrier and moves to conduction band. First we will discuss about holes and then we will come back to this question.